In this video, we'll solve a second-order differential equation using undetermined coefficients method. And the equation that we have is y double prime minus 5y prime plus 4y equals cosine of 3t. So the independent variable is t and the dependent variable is y. So keep in mind I wrote y, but it's actually y of t. So how do we solve this? Well, first of all, if we set y double prime minus 5y prime plus 4y equals 0, we are going to find the general solution or the solution of the homogeneous equation. So to do that, we write the characteristic equation, which is r squared minus 5r plus 4 equals 0. We can solve this equation by factoring, and the factors are r minus 4 and r minus 1, or quadratic equation, or whatever method. Now this is going to produce r equals 4 and r equals 1, which means the general solution of the homogeneous equation is c1 e to 4t plus c2 e to 1t, or t. So this is general. Now the undetermined coefficients method is helping us find the particular solution of the equation, knowing that the function to the right, it's a trigonometric function, and in this case it's cosine of 3t. So let's do that. Now the particular solution, looking for particular solution. So we have the general, I'm going to put that in a box to save it for later. So particular solution, because the function, because we have this equal cosine of 3t, we should expect that the particular solution has the form a sine of 3t plus b cosine of 3t. Also, another reason why it has this shape and no other functions are involved, it's because when we found the r's, r were 4 and 1, so they didn't have anything in common with this 3 from here. So we look for a solution of this form. So our goal is to find a and b, capital A and capital B. That's in the back of our mind. So how do we do that? Well, we are going to calculate the first derivative of the particular solution and then the second derivative, and we are going to replace them into our original equation to find the constants a and b. So the first derivative is going to be 3a cosine of 3t minus 3b sine of 3t. Then we do the second derivative the same way, so is negative 9a sine of 3t minus 9b cosine of 3t. So we take these derivatives and we replace them into equation star. So y double prime, so we're going to write minus 9a sine of 3t minus 9b cosine of 3t. So this was y double prime. So we just replaced this part. Now we have minus 5y prime. So minus 5 times 3a cosine of 3t minus 3b sine of 3t. So this part was replacing this. And then we have plus 4y. So plus 4a sine of 3t plus b cosine of 3t. So we just finish this part, equals cosine of 3t. So it's equal to cosine of 3t. So what I'm going to do now, I'm going to open the parentheses and get trigonometric functions on both sides. So negative 9a sine of 3t minus 9b cosine of 3t minus 15a cosine of 3t plus 15b sine of 3t plus 4a sine of 3t plus 4b cosine of 3t, I want to have everything together, equals cosine of 3t. So we have on the right side, we have cosine of 3t. So I'm going to try to write on the left side sine of 3t and some constants in front of it, plus cosine of 3t and some constants in front of it equals cosine of 3t. So I'm going to write all the terms in sine of 3t together. So sine of 3t, sine of 3t, and sine of 3t. So if we factor out sine of 3t, we end up with negative 9a plus 4a, that's negative 5a, plus 15b. This is the coefficient in front of sine of 3t. And then cosine of 3t, I'm going to highlight the terms in cosine of 3t, and I'm going to add the like terms. So negative 9b plus 4b, that's negative 5b, minus 15a equals cosine of 3t. So the sine of 3t from this side, the coefficients of sine of 3t from the left side have to equal the coefficients of sine of 3t from the right side. So negative 5a plus 15b equals 0 because there is no term in sine of 3t there, so that means the coefficient in front of it is 0. And then cosine of 3t from left side equals cosine of 3t from this side, so that means negative 5b minus 15a, and I can write negative 15a first minus 5b to have a under a and b under b equals the coefficient of cosine of 3t from right side, that's 1. So I ended up with a system of equations in two variables. I want to find a and b, so I'm going to multiply the first equation by negative 3, so I get 15a minus 45b equals 0, and negative 15a minus 5b equals 1. So if we add them up, we get negative 50b equals 1, which means b equals negative 1 over 50. And then replace in any of these. So I'm going to replace in the first one. So negative 5a plus 15 times negative 1 over 50 equals 0. So negative 5a minus 15 and 50 can be both divided by 5, minus 3 over 10 equals 0. So negative 5a equals 3 over 10. Divide by negative 5, so a equals negative 3 over 50. What does that mean, finding a and b? It means that our particular solution, y p of t, is equal to, and I'm replacing in what I'm highlighting now in green. Right, our goal was to find a and b, which we did. So y p of t is a, negative 3 over 50 sine of 3t, plus b, so minus 1 over 50 cosine of 3t. So in other words, the solution of the equation is the general solution, which we had c1 e to 4t plus c2 e to t, and then plus the particular one, which is what we just found, sine of 3t minus 1 over 50 cosine of 3t. So this is the solution of the equation that we started with. Now, and we solve it using the method of undetermined coefficients. In order to find C1 and C2, so if we were to find this, we would need initial conditions. We would need two initial conditions, and so from this form on, we would apply the initial conditions and find C1 and C2.